Hello everyone, I'm Lina. I'll be doing a technical seminar presentation on credit card fraud detection using machine learning and deep learning algorithms. These are the contents we'll be discussing in the upcoming slides. That is the introduction, objective, methodology, block diagram, result, application, conclusions, and references. In the introduction, I'll give a brief overview about what is credit card fraud and how machine learning and deep learning algorithms are contributing to credit card fraud detection. So let's begin with what is credit card fraud. Credit card fraud is anything with respect to identity theft, wherein somebody other than the owner is trying to make an unlawful transaction using a credit card or the account details. Sometimes there are chances of credit card being stolen, lost, or counterfeited, which may result to credit card fraud. So this has become a major concern for the financial institutions, merchants, and consumers worldwide. In this seminar, we'll be taking cases with respect to the year 2020 and have a detailed study of credit card fraud detection using machine learning and deep learning algorithms. So in the year 2020, there were about 393,000 cases of CCF, out of which approximately 1.4 million reports were of identity theft. The number of identity theft complaints has climbed up by 113% from the year 2019 to the year 2020, with credit card identity theft reports increasing by 44.6% following the government documents and benefiting the person who's doing the fraud. So due to all of this, the global economy had a backdrop of $24.26 billion last year. Now let's learn about machine learning and deep learning algorithms with respect to credit card fraud. So it can be used to detect and prevent credit card fraud. So in machine learning, we have two types of algorithms, that is the supervised machine learning and the unsupervised machine learning algorithms. So in the supervised machine learning algorithm, which can be used to build models that are trained on historical credit card transaction data labeled as either fraudulent or legitimate. So these models will be classified into new transactions as either fraudulent or legitimate based on their similarity to the historical data. Now let's move on to deep learning. So deep learning algorithms such as neural networks can be used to automatically learn complex patterns in the data and make more accurate predictions. So overall, the use of machine learning and deep learning algorithms in credit card fraud detection has the potential to significantly reduce financial losses and enhance the security of credit card transactions. The objectives of our seminar is to identify suspicious events, to recognize anomalies in real time, to minimize the risk of fraud, to ensure more secure transactions, to develop novel fraud detection methods for streaming transaction data. So in the methodology will be divided into 5 steps, that is data processing, pre-processing, building the model, classification, and finally the result. So in machine learning, there are two types of algorithms. One is supervised and the other one is unsupervised machine learning algorithms. So in the supervised, we know that it is a labeled data set, and in the unsupervised, we have an unlabeled data set. Okay, so there are different algorithms that can be used to bring good accuracy in credit card fraud detection. So in machine learning, the algorithms are SVM, logistic regression, KNN, decision tree, random forest, and etc. And now let's take a comparative analysis of machine learning algorithms, which will show high accuracy to detect credit card fraud cases. So this is the block diagrammatic explanation of credit card fraud detection using ML. So first step is loading of the data set. So in loading of the data set, what we do is we collect the data set from either Kaggle, or which is an open source, or you can get the data set from a financial institution, payment processor that is having an access to the transaction data. So these are the two methods wherein how you can get the data set. So currently the data set which I have presented in the screen is from Kaggle, and it is from the year 2013 September by European card holders. So these are containing features that is time, transaction time, amount, and location. Okay, so from V1 to V28 are PCA. PCA is nothing but principal component analysis. Principal component analysis, the thing that we have to remember is that it is an unsupervised learning technique which will reduce the dimensionality of the data, and also it will minimize the information loss. So the features, suppose which there are features which is very important for the accuracy or building the model. that will be determined by the data set. Okay. So in pre-processing of the data, it is in pre-processing the data set, whatever we have got, will be split into training and testing, where exploratory analysis is performed to identify patterns and relationship between variables. So there will be feature selection techniques such as genetic algorithms are used to select the most relevant features for classification. Other pre-processing techniques may include normalization, scaling, and handling missing values. So next, let's move on to building the model. So in building the model, we are going to determine the fraudulent and non-fraudulent transactions. We're going to split into training and testing. So in training, we are going to train the model, wherein in the testing, we are going to evaluate the performance of the model. Here we'll do feature engineering, wherein the raw data will be converted into numericals and without disturbing the original data set. Okay. So let's move on to result computation discussion, which is the last step of machine learning process. So in this, the performance of the model is evaluated using metrics such as accuracy, precision, recall, F1 score, AUC, ROC curve. AUC, ROC curve is nothing but area under the curve. Okay. So after scaling, the complete data is now ready for creating the model. That is, we have many different classification models like KNN, logistic regression, etc. Evaluation of the model, such classifier is evaluated on the given samples. The accuracy score and precision differ from each classifier. Later on, the comparison of model using the classifiers and which classifier showing highest accuracy will be taken into consideration. Now, these are the algorithms that are being used to find out the best classifier for detecting credit card fraud. So KNN, let's say KNN, these are all supervised machine learning algorithms. Okay. So KNN is one type of supervised machine learning algorithm because the data given to the set are labeled and we generally know supervised are labeled, right? So here the test set data are based on neighboring data set. Next, we have the logistic regression, wherein it is mainly for statistical analysis of data, which uses conditional probability. It mostly examines the more than one dependent variable, that is zeros or ones binary format. So that is what happens in logistic regression. SVM is also another supervised machine learning algorithm. They normally classify data based on a hyperplane. Hyperplane is used to divide the classes. Okay. Random forest classifier. They're normally applied next to data. Many decision trees together can be called as a random forest. Decision tree. This is one type of predictive modeling approach, and they're mainly used in statistics, data mining, and ML. So let's say what's data mining? Process of extracting and discovering patterns in large data sets that is called as data mining. Okay. Next is naive Bayes. Naive Bayes are mainly used when we have multiple classes. They're mainly based on probabilistic classifier by applying Bayes theorem in the given features. Let's move on to algorithms in deep learning for fraud detection. There are many algorithms, but these are the two important algorithms in this particular seminar. Okay. So convolutional neural networks are they are basically used on images. So it is widely used in computer vision and have become the state of art for many visual applications such as image classification. CNN has been used in credit card fraud detection to accurately identify fraudulent transaction using various machine learning methods. Next, we have the baseline model. So baseline model is basically used for the performance metrics, which is used to make it much more simpler, or maybe trying to identify whether the data set which is given is whether it is complex or whether it is simple or it is if building this model is really required for the business. Okay. These are the applications for CCF using ML and DL algorithms. It includes end-to-end model training, process that classify transactions into fraudulent or legitimate categories. Fraud detection modules involving machine learning and deep learning algorithms can determine whether upcoming transactions are legitimate or fraudulent. Finally, let's move on to the result. Okay. So in result, what did we learn up to now? Okay. That is all of it will be determined in the result part. So all the algorithms in machine learning, that is KNN, SVM, decision tree, logistic regression, all of this, and the deep learning models such as convolutional neural networks, recurrent neural networks have all been proposed in it. So comparative analysis with respect to machine learning and deep learning is done. And the goal in this is to develop a model that can accurately classify fraudulent transactions while minimizing false positives and false negatives. So this is the accuracy score of machine learning models. So you can see here, let's take the accuracy and F1 score let's take the blue line as 100% and the orange line to be with respect to 100%. Okay, F1 score. So if decision tree is showing around 80% accuracy, wherein Kane is showing about 82, logistic regression is showing about 70, SVM is showing about 78 to 79, and RFT, that is random forest, is also showing about 78 or 79. Okay. So this is the accuracy score of machine learning models. This is the comparative analysis of machine learning and DL algorithms. So these are all the existing accuracies, and this is a new accuracy, and the one with the highest accuracy is SVM as well as decision tree. So I'd like to conclude by saying the performance of ML methods will vary for each individual business case. Let's say for detecting CCF, the number of features, number of transactions, and correlation between the features are essential factors in determining the model's performance. Using these methods for the detection of credit card yields better performance than traditional algorithms. Comparing all the algorithm performance side to side, the CNN with 20 layers and the baseline model is the top method with an accuracy of 99.72%. Numerous sampling techniques are used to increase the performance of the existing samples, but they significantly decrease on the unseen data. Future work associated may explore the use of more state-of-art deep learning methods to improve the performance of the model proposed in this study. So these are the reference papers I've taken into consideration for our technical seminar today. Thank you. I hope this session was informative, and I guess you would have got a brief overview and idea about credit card fraud detection using ML and DL algorithms. Once again, thank you.